We are done with the first four concepts with respect to the queues, and now we'll see this circular queue. What is this circular queue, how it is different from a simple queue, and what are the operations you can do, and the program as well as execution. Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus. If you see the definition of circular queue, insertion of new element is done at the very first location of the queue and provided that the last location of the queue is full. So I'll take two examples here. For example, if I want to insert an element here, let us suppose take a instance like initially queue is empty, means f equals to r equals to -1. Now I want to insert an element where I want to insert 5 here, then f will be here, r will be here. Then I want to insert 10, so r will become here, then 15, r will come here, then might be 25, r will come here, then 20, r will be here, then 30, r will be here. So like this we have front and rear. Now after this, let us suppose I want to delete an element here. Let us suppose I want to delete this element. So the element 5, I want to delete it. So now the front will be here. Now the front will be here. Still if I delete 10, of course rear won't be changed, of course front will be here. Now still I want to delete, yes, you can delete it, your front is here. Now you observe, in this case I want front is here and rear is here. In this case I want to insert an element. In general queue, if you use what it says, r is at which position? At the last position. So that means you cannot insert the elements. It says like queue is full. But in general, if you see, is that queue is full actually? No. Why? Because there are enough spaces from the front where you cannot insert the elements in a simple queue. Let us take there are 1000 elements you can insert into a queue where you inserted only 10 elements you have at the last positions. But in the front part you have 990 free spaces are there which you are not able to use if you use simple queue. So that's why we'll go for the concept of circular queue. That means if rear is finished, now you want to insert the elements from front. One by one you want to insert from front. So that is what the concept here you can make it. Let us suppose I want to insert now 40. Yes, you can check it out, at the last it is full. So insert 40 here. Now your front is here and rear will be here. Okay, then how the code will be changed, we have to write actually. So let us suppose one more element 50 here. Yes, you can make it. Then one more element 60 here. Yes, rear will be here. Now you can say it is full. So what is the extra condition, you will get it. That is also we'll see here. Okay, so all these things will be there in the circular queue. That is what the main advantage if you consider circular queue over simple queue. That means where in the general queue, if rear is equals to n-1, size -1, so definitely it says queue is full, which actually not. But where at the leftover spaces, if they are at the starting, which you want to fill it up, you can go for circular queue. So that means this will be like this cycle. So where the elements are stored like this. So which is the first element, it might be 25 at front, 20, then 30. Yes, you can go for it. The next element 40, next might be 50, next might be 60. If 25 is deleted, yes, you can keep it here. It's a circular. Now what are the operations you can do in the circular queue? So mainly I'm pointing out how to make it Enqueue. Insert an element into the queue, how you can make it. In general, we have seen already how to make it in the circular queue. So Dequeue also, how to make it, how can you check it out whether your queue is full or not. Okay, so of course is empty. This is in general, this is very simple, queue is empty. It's same like simple queue, but the remaining 3 will be changed like Enqueue, Dequeue is full. So which conditions you have to write extra and where you have to make the changes, everything we'll see with respect to program also. So here what I'll do is we have written already the program on queue, simple queue. So in that I'll make updates so that you will come to know like what exactly the changes has to be done. So that is a program which we have already written. That example I'll take where I want to modify the things so that it will become a circular queue. So we'll see that. So let us suppose this is a queue. Initially the queue is empty, f equals to r equals to -1. Okay, yeah, I'm taking here how many values I've taken. 6, right? Okay, might be. I'll take here also n equals 6. So f equals to r equals -1. Now I am implementing circular queue. So Enqueue choices you are taking. What is the front element? Of course, you can directly get front. What is it? Is empty. You can check it out. Is full, and display also. How to display? That is also very most important. From front to rear. Not exactly if you see it you queue. Front to rear, how to make it? That also we'll see. So enter the value to insert. Enqueue fine. Dequeue fine. So each and every function, how? First thing is enqueue. When you insert, what are the things you need to check it out? So we'll see first thing. So what is that? It is written if r equals 10 minus 1, queue is overflow. Now this has to be changed anyway. Now first thing, I'll check it out this one. If f equals to -1, what is f equals to -1? Queue is empty. See, if queue is empty, you can directly say that f equals to r equals to 0, right? Queue is empty means f equals to r equals to 0. So that means you can keep it here an element. Let us suppose I want to insert an element 5. So index 0 I'll write here. So this is the element 5 you can keep, and f and r will become 0. This is absolutely fine. Okay. Now next element. Okay, f equals -1, fine. Next element, what is that? Let us suppose 10. Is that r equals 10 minus 1? What is n actually? 6. So 6 minus 1, 5. What is r value? Anyway, front is here and rear is also here. F equals to r equals to 0. Okay, I'll write it separately so that they are changing, right? So f equals to r equals to n equals to anyway 6. F equals to initially -1, r is -1, then they became 0. Then when I insert 10, only r will be updated, this function. The thing here, this r equals to n minus 1 is not true, else q of plus plus r. What is plus plus r? Means r value will become 1 and I want to insert the value. Okay, next 20, yes, next 20 is also fine. I'll insert and r is 2. Next 30, yes, I'll insert 30 and r equals to 3. At rear is here. Okay, front is here only. Next 40, yes, you can insert. Next might be 50. So I'll insert, so that r is becoming now 4 and 5. So this is what you can make it fine till now. Okay, now let us see if you go for delete what you have written here. Okay, so let us suppose if f equals to -1, q is underflow, that means that is absolutely fine. Next, else if f equals to r means only one element, then you can make this is absolutely fine. Now the else part you can see. Let us suppose I want to delete. If I delete this one, now front is updated. What is front becomes? Okay, I'll update, I'll write it here. This is rear is finally, what is our output here? 5. Front is now 1 after deleting this. Now after deleting 10, front will become, anyway I'll write here completely, front will become now 2. So front is at position 2. You want to delete one more? Yeah, I'll delete one more. Front is at 3. Front is at 3, rear is at 5. We'll see this situation. Front is here and rear is here. Now let us suppose now I want to give you the option as inserting an element. What is the logic we have written here? If you go for insert, r equals, what is r? 5. What is n minus 1? 6 minus 1, 5. Both are equal, so it gives overflow, but it should not, right? Here, so we have to enter at the first, so we have to write that logic here. So now when it is overflow, you forget about that first thing. Now you need to check it out one more condition. What is that? Is if r equals to, instead of n minus 1, okay, first we'll write this one. First condition we are writing, the first point is if f equals to -1, yes, f equals to r equals 0, this is fine, which is empty. Else if I want to check it out one more condition, what is the condition here I want to write is, else if, okay, if r is equals to n minus 1 and also f is not equals to 0. Of course f is 0 means yes, I can say it is q is overflow, but f is not 0, you can see what is f3. So then what you need to do, you have to insert your element here. Am I right? So your element, let us suppose 60 to be inserted here, means your rear will be here. Means what? Means what? Your r is equals to 0 and what is Q of R, which is equals to the current element. Is it right? Now you can make it finally else part. So now you can make it what is if not else plus plus R, you can make it. Now the thing which we forgot is when can you print as Q is overflow. When you can print, let us suppose you inserted 60. Now you want to insert 70. Yes, you can insert, right? So where R equals to n minus 1, but f is not 0, but it goes to the else part here. So Q of plus plus R, which is 1 and value, next 80 here. So R value will become anyway 0, 1, 2. Now if you clearly observe when it is Q is full now you clearly observe what is f value 3, R value 2. So this is a one extra condition you need to check it out. If f equals to R plus 1, so f is here, R is at the back position, then also you can say Q is full, right? So that is also very most important part, you need to check it out. Okay, so that is what I'll check it out here. So now I'll write one condition here, you can see one more. If f equals to minus 1, yes, it is fine, but else if here I want to write what is the condition for overflow. Okay, I'll first print it. So printf, what is that we need to write here as overflow. Q overflow, actually we have to write. So what is the condition for overflow here? Okay, in general we say that f equals 0 and R equals to n minus 1, first condition, right? So else if I'm writing here, you can see f should be 0 and also R should be, this is a condition for the first simple queue, but here in a circular queue not only this R, another condition is what? F is double equals to R plus 1. If any one is true, yes, you can make it, right? So this can be rewritten as any simple way. I'll write it's a simple way which is applicable for both the things, which is I'll write here as what is R plus 1. I'll check it out. What is R plus 1? I told you, which is equals to f. This is applicable first thing, but this is applicable for the last element? No. So for that I'll write R plus 1. I'll make it as percentile, what is the maximum value, n. R plus 1 percentile n is equals to f, then also it is overflow. Let us see this condition how it is true. If you see where f is here, R is here, then you can see what is R plus 1, 2 plus 1, 3. Yes, this is fine. What if f is 0, R is last 5, then will it be applicable? You can say what is R? 5 plus 1, 6 percentile 6, 0. Yes, equals to 0. So for both it is applicable. So that's why we have written this condition, straightforward condition we have written for the both. It's a shortcut. You can simply write like if f equals 0, then R equals n minus 1, or R plus 1 is equals to f, but this is a straightforward, directly you can get the condition. Now we have written for Q overflow, and if it is empty, what you need to do, we have written. Now else part we'll write, instead of making this statement directly, instead of writing everything, I'm writing, you can see finally else part. So if this is not, that means Q is not overflow. What you need to do, you need to increment R value first. Okay, anyway you incremented R value and you are storing, but what if R value is the last? Let us suppose R value is 5 plus 6. Instead of 6 it needs to become 0. It's a cycle. See, whenever there is a cycle, whenever your index is a cycle, like it should go from 0 to n minus 1, again it has to come to the first, means you need to remember the condition about percentile operator, which is R equals to, I want to write what is R plus 1, you have to make it anyway, which is percentile n. What happens, you can see Q of R plus 1 percentile n I have to write first, and anyway I'll write Q of R. So how it is, how it will give the correct answer, we'll see. Let us suppose the situation is like this. So where f is at 1, R is at 5, anyway n is at 6. Now you can see it's not full actually. These conditions are false, else comes it is R equals to, what is R equals to 5 plus 1, 6 percentile 6. which is 0. So R comes to 0. Is that right? So where you have to keep. If it is not 0, let us suppose there is no element here. R value 4. 4 plus 1. 5. 5% L6. 5 only. Right? 5% L6. 5. So this is a unique one. You can make it for where you want to insert the elements. So this is where you can make it, how you can insert the elements into the what you call it as queue. So Enqueue, this is into the circular queue. So the first thing which is empty, yes, you can make it directly. If equals to R equals 0, you can insert. Else if you are checking what is this any overflow, what is the condition? R plus 1 percentile n. So you are checking and going, if R is at the last plus 1, at the first you are checking, is that F is there? No. Then you can get overflow. If not, you can insert the elements. So these are the things you need to update with respect to circular queue. Now about deleting the queue, deleting the elements into the queue. Let us see. If F equals -1, queue is underflow, it's absolutely fine. You cannot change anything. It's absolutely, you can make it. If F equals to R, yes, %LD deleted, which is the element deleted, you can make it one element. Now here you can see, if you want to delete it, let us suppose the elements in general, how you can delete is, you can delete the front element. What is the front position? From that you can delete, and F++, F has to move there. But one thing we need to observe, the situation you can see, where of course we are taking in a reverse order. Let us take this situation where front is at third position, and also let us go for one more element here. So rear is at 0 position. So that means the elements are 30, 40, 50, then 60. So rear is here. So rear is here, front is here. So I want to delete front element. So what is the front element? 30 will be deleted, F++. So it will be deleted, Q of F 30 and F++, F goes here. This is absolutely fine. Now take another constraint. Let us go for this constraint where front is at 5th position, rear is at anyway 3rd position. Front is at 5th position, rear is at 3rd position. Now if I delete, which element to be deleted? 50 should be deleted, and then front has to come to 0. But if I write F++ means it goes to 6th position. Is there any 6th? No. So that's why what you need to do is, instead of F++, what is F value to be updated? F equals to, again the same thing like F plus 1 percentile n, so that it will come to the first position. You can see 5 plus 1 6 percentile 6 0. So now F is at this position. So this is some edge conditions we have to must observe, F and R. So what if F front is at the last position? You can have, right? So then F equals to F plus 1 by 1 percentile n. So these are the few modifications you have to check it out with respect to the queue compared with circular queue. So let us once again go for it. We have taken n equals 6 and then F equals to R equals -1. We have written Enqueue all functions here. You can see Enqueue F equals -1 means empty queue. Then you can insert the element given. Else if this is for applicable for, even if it is the element you want to insert, if the size R equals to n-1, how to insert from the first, this is applicable, which is this is applicable, else part, and this is for the overflow. What is overflow? Means the queue is full, even from the first also you can consider. Now Dequeue, so that means you want to delete. If F equals -1, queue is underflow, no element. And then else if F equals to R means only one element in the queue, yes, you can delete it wherever it may be. Else %LD deleted, F equals to F plus 1 percentile n. So this is what edge condition also covers, where F is at the last position. That means 50 should be deleted and your front has to come to 0. Then 0 to R you will get it. Okay. Now the main thing, display function, which is very most important. In general F to R you can go. Okay. But now assume my what you called as my queue is like this. Let us assume my queue front is at 3rd position, rear is at 2nd position. Means assume that elements are like this. The elements are 30, 40, 50, 60, 70, 80. Okay. So that means 30 is at 3rd position like this, 3, 4, 5. Then coming to the first position 0, 1, 2 has to be printed. Right. So then how can you make it in general? So that means your queue I mean, you have to display anyway. F equals -1 means absolutely fine, Q is empty. Now your I equals to F should start. What is F value? 3. 3 means Q of I, it will print what? 30. Next I plus plus 40 will be printed, I plus plus 50 will be printed. Next, what is the next I value after 5? 6. So will it be printed 60? No, 6th element not there. So how can you make it to the first? So that is what very most important. For that, so we need to write like this. The first thing, when you want to print it, okay, else if, okay, we need to write one condition. What is front and what is rear? If rear is greater than front, yes, you can print it in a straight way. If rear is less than front, then you can print it in another way. So that is what we'll write here. If rear is greater than front, then you have to start I equals to F, I less than R, I plus plus, and you have to print each and every element in the queue. %LD, comma, Q of I. Now it's not. Let us suppose rear is not greater than front, else part. Okay, both are equal. It might be whatever. Okay, how to print them? So you have to print like first print till the last, then print from the first. So something like this. For example, for I equals to starts with front. Okay, starts with front up to the last, I less than n, I plus plus. So printf %LD, comma, Q of I, and also for I starts from 0 up to the rear, you have to print it, Q of I. So two conditions. So where your front might be your rear might be back of front, so how to print it? If not, how to print it? So that is what we can write here. Anyway, can I make it rear is greater than or equals to? Yeah, absolutely fine, right? So otherwise you can make like this. Yeah, let us see the output. The variable I to be declared, I'll declare here int I is empty. You can check it out if F equals to -1. Is full means, yeah, here it's a one more constraint. What is a is full condition? I told you already. So you can take from here is full. Yes, R plus 1 %Ln is equals to F. This is for Q overflow, means it's full already. So instead of this, what you need to write is, if you have R plus 1 %Ln means equals to F, means yes, written 1. So let us see this, how we can get it. If it is 10 and enter the value 10, so only one element. Let us see whether it will display properly or not. So 7, yes, printing. I'll insert one more element 20. I'll insert one more element 30. Will it display? Yes, 10, 20, 30. I'll insert one more 40. Yes, will it display? Yes, 50. Then I'll insert 60. So queue is full now. So let us see the display part. So now like this. Let us see, I'll delete 10. So the display is fine. I'll delete the next. Yeah, the display. I'll delete the next, the display. You can see. So one more thing, option 2, which is 30 deleted. Only 3 elements are there. Now I'll insert at the first, you can see. So might be I'll insert 10 here at the starting. Is it inserted successfully? Yes, but the display? Yes, you can see. Perfectly fine. I'll insert one more. So it's not saying that queue is full, you can see. So the display part you can see. Now it is inserted from the back 40, 50, 60, 10, 20. One more space is also there. You can insert 30, let us suppose. As you can see the display. Now can I say queue is full? You can see option 6. Yes, absolutely fine. Will you insert one more element? Let us see. One option if I give. If I want to insert 40, yes, queue overflow. See the now the things are there like this. So the inserted queue will be looks like this: 10, 20, 30, 40, 50, 60. But that front is here at this position, but rear is here. Now, so if you delete, which will be deleted? 30 has to be deleted. You can see the options. Option 2, which will be deleted? 30. Sorry, 40. 40 is here, right? So lastly you inserted 40. Sorry. So lastly you inserted 40. So R is here, F is here. So 40 has to be deleted. So 40 deleted. Of course, you will see the display part first. Yeah, 50, 60 you can see like this. Now what is the last element? 30. If you delete, 30 has to be deleted. Yeah, I confused. Okay, previously it is correct. 40 is the front element which is deleted. Next 50, 60 are there. What is the front element? 50. 50 has to be deleted. Yes, you can see 50 is deleted when I go for it. Now you see the display part. So 60 is our front element, right? If I insert, which will be inserted after 30, you can see the insert 40. Yes, you can see the display part like this. If you delete it, 60 will be deleted. Yes, absolutely fine. Now you can see your front has to come to the first position, you can see. So that is what you can see. If I delete and if I see the display part like this, what is front? If I ask you, that index 0. Of course, we didn't write r plus 1 percentile. For that you will get it anyway. That front, which is we didn't update actually. Return Q of f, what you call it as f plus f percentile n has to be written. Return f percentile n. Let us see this one also, why we have written f percentile n. Let us see. Yeah, let us suppose if the elements are like this, 110, 120. So the display is like this. Now what is 3? Option 3. 10 is the first element. Now if I insert all the elements, so the display is like this. Now if I delete 2, 10 is deleted. If you see the display, what is the front element? Index is, of course, the element is 20. You can see. Of course, previous also, which is correct. F is directly. Anyway, we are updating. So like this, we need to implement. Those who are executing, they can check it out. This is about circular queue, and I am erasing this part. So this is about circular queue. You can execute like this. You can just see the changes, and according to that you can update and you can get the answer. This is very most important here, how we are printing the line number 64 to 74. So we are done with circular queue also. Now we'll see in the next video lecture, we'll see double-ended queue with program and execution. Thank you.